Hi everyone, good day. This is Navimia Maglasang, and I will be continuing the report of precipitation titration, focusing on the two other methods of organometric titration. These are Volhard'S method and Mohr'S method. And apart from that, I will also talk about limitation and application of precipitation titration. But first, let's talk about Volhard'S method. So Volhard'S method was being published by a German chemist named Jacob Volhard in 1874. It is an indirect or back titration method in which an excess of a standard solution of silver nitrate is added to a chloride-containing sample solution. This method determines halide ions such as chlorine, bromine, iodine, and an ion such as phosphates and chromate in acidic medium. It uses iron ions as indicators. Oxidizing agents such as AgNO3 or any anionic solution is used to titrate the acidic first analyte or halide ion solution. So in conducting precipitation titration or titration itself, there is a need for burette and a conical flask for that to be possible. And with using Volhard'S method, the solvent is water, the analyte is sodium chloride, the titrant is ammonium thiocyanate or potassium thiocyanate, the indicator is ferric nitrate or ferric ammonium sulfate. So the procedures are: the first reaction is the excess AgNO3 is being mixed up with the NaCl that forms a precipitate of AgCl alongside with NaNO3. So if you're asking if asa ni siya makita or giunsa ni siya, so unfortunately I cannot give you the proper or the correct demonstration on this, but what I will be showing you is the presentation on where these things can be found. So niana man ta didto nga ang pagmix sa AgNO3 sa NaCl kay naka-create siya AgCl. So looking in the image and the left side facing your phone screen or facing the monitor of your monitor, ang kaning first sa conical flask is ang AgCl, which is na-form siya sa reaction sa AgNO3 o sa AgCl. And then dirita sa right, mo na siya ang conical flask o ang burette niya. And then niya naman tanga ang AgCl na precipitate. So same with this, ang kaning white nga naa diri is diri gid naga-place ang iyahang AgCl nga naga-precipitate. And then diri sa nagrepresent sa sample containing chloride ions, i-disregard lang na siya nga text, but dira nato ma-find ang atong excess AgNO3. And diri sa burette, dira naga-place ang atong ammonium thiocyanate. So the excess AgNO3 is titrated against the NH4SCN in the presence of ferric nitrate. So proceed na ta sa atong second reaction. So niana ta nga ang atong AgNO3 is titrated against or mixed up with the NH4SCN. Sa pag-react nila, naka-form siya og AgSCN alongside with NH4NO3. So it is mixed up and open the burette and reacts with AgNO3. So ang burette gi-open nato to mix up the NH4SCN with the AgNO3 that results to AgSCN. So there nasad ta sa right nga image or right nga photo. Ang nasa middle nga conical flask is the result or is the AgSCN nga result siya sa NH4SCN og AgNO3 nga reaction. As you notice kanang kuha na siya kanang darker yellow na siya or padung na siya mo brown. So mo na siya ang atong formation sa second reaction. So diri na ta sa ikatulong nga reaction, which is the ferric nitrate reacts with the NH4SCN that forms a ferric thiocyanate. It precipitates down alongside with 3NH4NO3. So when AgNO3 is completely reacted with all the NH4SCN, so nagbuot pasabot na siya nga ang precipitation mas stop na. And then NH4SCN reacts with the indicator and forms red-colored and ferric thiocyanate. So if maka-form na siya red-colored or ma-form na ang ferric thiocyanate gikan sa reaction sa ferric nitrate o NH4SCN, dira na ta maka-attain sa atong or maka-ibaw nga nanata sa atong endpoint. It reached the endpoint na jud. So, balik na sad ta. So, the third conical flask from left, mo na siya ang red-colored nga ferric thiocyanate, which is the formation or the result sa atong ikatulong nga reaction, which is naka-attain na ta sa atong endpoint. So, let's proceed. So, here is the calculation of concentration using Volhard'S method. So, what we are going to calculate in this is the concentration of chloride ions. So, let's get started. So, a 50.0 ml of a solution containing an unknown concentration of chloride ions is added to 50 ml to a 0.0500 mole per liter solution of silver nitrate. The precipitation is filtered and the filtrate is titrated with 0.0200 mole per liter solution of sodium thiocyanate. So, ang atong reaction na ni is Ag plus in aqueous solution reacts with SCN negative in aqueous solution forms a precipitate of AgSCN. So, the average titer volume after 3 repeats is 25.00 ml. Then, mag-calculate na ta sa atong concentration of chloride ions in the solution in mole per liter. So, we should all be reminded na ang kaniyang reaction is in 1-to-1 ratio. It means nga ang number of moles sa SCN negative is the same siya sa number of moles sa Ag+. So, para maka-find ta sa number of moles sa SCN negative, we need to multiply the solution of sodium thiocyanate sa quotient sa atong average titer volume after 3 repeats, i-divide sa 1,000. So, maka-result or maka-kuha ta og 0.0005 mole. So, kay 1-to-1 ratio man, so pareha na siya value sa exist a number of Ag+, so nasayop lang na siya dira. So, ang tinuod jud nga answer is 0.0005 mole. Kuha nga na siya 0. So, proceed ta sa number of moles sa initial nga Ag+. So, it is 0.05 times 0.05. So, kuha na siya ang solution containing an unknown concentration of chloride ions. Mo na siya converted into liter. Kay 50 ml man siya, ma-convert siya into liter. So, mahimo siyang 0.05. And then, equals to 2.5 times 10 raised to the power of negative 3 mole. So, proceed na ta sa reacted number of Ag+. So, makakuha na to siya in subtracting the initial sa exist niya. So, ang initial niya is 2.5 times 10 raised to the power of negative 3. I-minus siya sa 0.005. And that would equals to or result to 2 times 10 raised to the power of negative 3 mole. So, ang proceed na ta sa number of chloride ions. So, since 1-to-1 ratio naman gihapon na siya, so parehara na siya og value sa reacted number of moles sa Ag+. So, which is 2 times 10 raised to the power of negative 3 mole. So, proceed na ta sa concentration of chloride ions. So, in calculating the concentration of chloride ions, there is a need for the kanang number of chloride and sa volume of and the concentration of the silver and the concentration of the chloride ions sa kuan pa na siya before sa experiment, so which is 0.05 liter, na-convert na siya from ml to liter. So, it is equals to 0.0400 mole per liter. So, kuan na siya kanang there is somewhat libog siya, pero dili ta dapat maglibog if we are going to just follow the procedures and try to convert things for the uniformity of the units. So, proceed na ta sa Mohr'S method. So, Mohr titration is defined as the type of titration in which the chloride ion concentration of the given solution is determined by titrating it with silver nitrate. So, kay sa Volhard'S method, kay ang silver nitrate i-add sa chloride ion, ang chloride ion is being determined by titrating it with silver nitrate. So, as you notice, kanang parihara gyapon nga chloride og silver nitrate, but there is a difference on the procedures to be made with the reactions nga atong himuon ani nga mga methods. So as I've said a while ago nga kinahanglan og burette organical flask for the precipitation titration to be conducted. So ang solvent aning in Mohr'S method is water gyapon, analyte is sodium chloride, the titrant is AgNO3, and the indicator is the K2CrO4. So the procedure, so first reaction is NaCl is being reacted with AgNO3 that results to a precipitation of AgCl together with NaNO3. So this reaction takes place when we open the burette a little bit or dropwise. So muna to, same ra gihapon siya og kanang demonstration or presentation sa katong burette organical flask nga atong i-open ang burette para ma-mix siya, and it will result to AgCl. And if mag-ask gihapon mo asa na place ang AgCl, so ang AgCl kay ni precipitate man siya, so usually na siya sa bottom. And then dire when all the NaCl has been exhausted by forming the AgCl precipitate, so mo proceed ta sa second reaction, which is the last drop of AgNO3 solution reacts with the indicator to form silver chromate. So mo na siya nga ang AgNO3 reacts with K2CrO4, maka-form siya precipitate nga Ag2CrO4 together with 2KNO3. So the Ag2CrO4 precipitates and forms a brick red PPT that represents the endpoint. So maka-notice mo nga kanang it takes two reaction para maka-attain ta sa or maka-form og brick red para ma-represent siya sa endpoint, and then sa Volhard'S kay 3 reaction siya para makaadto ta sa ayang endpoint. So yeah. So and the third procedure is to analyze the concentration of chlorine present in our analyte. So first we need to measure the amount of AgNO3 to obtain the endpoint, and we should be careful aniya if kanang unsaon na siya pag-measure, kay there is a possibility nga if kanang unsay like naay kanang what you call to this one problem if marong na dayon ka. So second is the reduced value of AgNO3 inside the burette denotes the amount of AgNO3 required to form an equivalent amount of AgCl. So ang amount sa the reduced value of AgNO3 is quantity siya required siya para makakuha ta sa equivalent amount sa AgCl. So from the amount of AgCl formed, you can calculate the amount of chlorine present in the analyte. So proceed na ta. So proceed ta sa calculation of concentration using Mohr'S method. So same ra gyapon nga atong pangitaan is the concentration of chloride expressed in mole per liter. So the problem is, or the situation is, excess amount of a 0.0500 mole per liter solution of silver nitrate is added to 50 ml of a solution containing an unknown concentration of chloride ions. Some amount of potassium chromate is added and used as the indicator. The endpoint of the titration is marked by the formation of silver chromate ion according to the reaction. So ang iyang reaction is ang 2Ag plus in aqueous solution plus CrO4, 2 negative aqueous solution forms a silver chromate. Then the average titer volume after 5 repeats is 18.50 ml. So let's proceed. So 1-to-1 ratio ra gihapon na siya. That means nga ang number of moles sa chloride ions is also the exact number of the Ag+. So in finding the number of moles sa Ag+, we need to multiply the value sa solution containing an unknown concentration of chloride ions before sa experiment. I-times siya sa quotient sa average titer volume divided by 1,000, 18.50 divided by 1,000, then it would equate to, or it would result to 9.25 times 10 raised to the power of negative 4 mole. So since 1-to-1 ratio lagi siya, so ang number of moles sa Ag+ is also the exact number of the number of moles sa chloride ions, so which is 9.25 times 10 raised to the power of -4. So let's proceed to the concentration and calculating the concentration of chloride ions. So in finding the concentration of chloride ions, we need to use the value of the number of moles in chloride ions, and it should be divided in the concentration of the unknown solution sa unknown concentration of chloride ions, which is 0.05 liters. As you notice, kana siya 50 ml, and we need to convert it into liters since mole per liter man ang kinahanglan. So which is 0.05 liter. So that would result to 0.0185 mole per liter. So I hope nakasabot ra mo ato, and if you don't, then please do research, or please don't hesitate to ask me. So proceed na ta sa limitation in Mohr's method. So there are 3 na akong na-research on the limitation in Mohr's method. So first is acidic medium. So pH below 7. So the silver chromate, which gives the endpoint, will dissolve. And if ma-dissolve ang silver chromate, there is a possibility nga faulty endpoints ang atong ma-attain after the procedure. So solution to that is we need to add base like calcium carbonate or sodium bicarbonate to make the solution back to neutral pH. And then the next one is basic medium. So if greater than 7 gyapon ang pH, our titrant AgNO3 degrades to form AgOH. So there is a problem with that also. So ang solution gyapon ana is mag-add tag acid like acetic acid to make the solution back to neutral pH. So whether acidic medium or basic medium, kay ang common goal ra gyapon nato ani is for the acidic solution to be neutral, and for the basic solution to be neutral. So we need to attain neutral lang jud na siya dapat. So yeah. And then the last one is the iodine. Iodine cannot be analyzed by this method because when the analyte for iodine, that Ki reacts with AgNO3, then it forms KNO3 and AgI. So the reaction of Ki plus AgNO3 results to KNO3 plus AgI. So the silver iodide absorbs the chromate ions that disturbs the indicator, and that will result to faulty endpoints, which is atong gina-avoid nga maka-attain or maka-result tag faulty endpoints since there is a problem in analyzing pod sa endpoint, and kanang very crucial siya in a way nga dapat ma-attain nato ang expected nga endpoint sa usa ka method sa precipitation titration. So next to that is the limitation of precipitation titration. So there are 3. So first is only very few halide ions can be titrated using the precipitation titration method. And then co-precipitation also occurs. Then the endpoint is very difficult to analyze. So mo na siya akong ginaingon nga difficult siya to analyze in a way nga there is a need for you to be careful on the procedures nga imong i-make dayon ang amount pod sa every solution nga imong involved sa procedure or sa experiment. So the last one is the application of precipitation titration. So first is it is used for the determination of halide ions in the solution. Next to that is it is used to measure salt content in food, beverages, and water. It is used for sulfur thiocyanate, diachromate. Many drugs such as carbonyl, KCl infusion can be analyzed by precipitation titration. And last is it can be used for the determination of concentration of an ions in the analyte. So ori ko naka ibaw nga dili lang jud ni siya barely nga anong experiment lang ni siya for some chemicals nga naalang joy mahimo napod din ni siya involvement sa everyday life nga atong everyday life, and then sama ani nga maka-measure din siya og kanang salt content sa food or beverages and water nga atong gina-enjoy sa atong everyday nga kanang living. So I hope you do understand this lesson, and if you don't, then please don't hesitate to ask or ask Google for queries or for clarification or for more understanding sa kani nga lesson, since I am having a hard time pod on understanding this lesson. So I hope just like now lang may bawaan nga kanang bisag kinagmay lang nga lesson sa kuang part sa report. So that's all. Thank you.